we're solving problem 13 from the 2023 AIME 2. Let A be an acute angle such that tangent of A is equal to 2 cosine of A. Find the number of positive integers n less than or equal to 1,000 such that secant n of A plus tangent to the power of n of A is a positive integer whose units digit is 9. So we are given this property right here, tangent of A is equal to 2 cosine of A. Now this is very important because we can use this for some trigonometric manipulation. So from this, we get that sine of A, sine of A is going to equal simply, because this is tangent of A, this is going to equal 2 cosine squared A, because tangent of A is equal to sine of A over cosine of A, so then the cosine just multiplies over. So we all know that, hopefully you should know this, but if you don't, it's okay. It's just sine squared of A plus cosine squared of A. A is any angle, any value. This is always 1. So we can use this and plug this in because this becomes 4 cosine to the power of 4 of A plus cosine squared A equals 1. This is the identity from this. And this here allows us to solve for cosine squared of A. Cosine squared of A after solving, we get square root of 17 minus 1 over 8. That is what we have right there. Now, we want to find this when it's a positive integer whose units digit is 9, and we have n is less than or equal to 1,000. So if we just say c sub n is equal to secant, secant to the power of n of A plus tangent to the power of n of A, we can further simplify this through trigonometric reasoning. This becomes 1 over cosine to the power of n of A plus 2 to the power of n cosine to the power of n of A. This further becomes 4 cosine squared of A plus 1 to the power of n over 2 plus 4 cosine squared A to the power of n over 2. So once we get to this point, you set x to be equal to root square root 17 minus 1 over 8, x to be plus 1, and then y to be the minus 1 here, and then divide by 2 instead of the 8. So then you do that because you ultimately want to list out some identities, some things, and then you want to have like equations for n that satisfy those those things that we have to list out, those these properties. So I mean, this is a long process, so I won't write it out because I don't want to take up all the space. But once you successfully write out all the properties, you will find that we have n is either equal to 12k plus 4, or n is equal to a 12k plus an 8. And this is assuming that n is, if it's like this. If it's like this less than or equal to n, capital N, right? The total number, then that means that we have this unique property, and the floor of n over 4 minus the floor of n over 8. This is going to be our answer. Now we have to plug in 1,000 because that is what we have as our max. So then 1,000 over 4, take the floor of that, subtract 1,000 over 8, and the floor of that. This is going to be 167, which is our answer for this problem, and we are done.